This is the conic sections, and we're going to be discussing circles and parabolas. You'll have to forgive my voice. I am not at peak. I'm a little bit sick, so just excuse my sniffling or my coughing. Circles. This is probably one of the more easier pieces of a conic section. This is something we're used to. This is something you see all the time. We have the basic circle formula, or standard form of a circle, where you have x minus h squared plus y minus k squared equals r squared. And I've denoted that hk is my center and r is my radius. Be careful. R, sometimes it's real easy just to think that it's equal to the radius, but it's equal to r squared, so you have to take the square root of the number to find your radius. One of the most common problems we asked is to take something that's written in a form like this, and I ask you to re-evaluate that or convert that into the standard form of a circle like we have at the top. So what we do is we take this value, or we take these equations, and we're basically going to use the technique completing the square to rearrange it and put it into the form that you see up top. So step number one, we want to arrange our x's, our y's, and the constant values in the form that you see basically in the standard form. So I get the x's together, I get the y's together, and I get the constant values on the other side of the equal sign. And you can see that here. We put the x parts together, we put the y parts together, and I put my constant variable. And I left a blank intentionally. The blank is there to remind me that I'm going to complete the square. I'm going to add something to both of my pieces. And so the secret, or the trick to completing the square, is to remember that we use b over 2 squared to add each part. And you can see here, this is my b term. Of course, it's the number in front of my x. I take half of that and square it. So half of 2 is 1, 1 squared is 1. Half of 6 is 3, 3 squared is 9. And have corresponding parts on the other side. Remember, what you do to one side of an equation, you must always do to both sides. And so I went ahead, I factored this value, the first of the x parts, into x plus 1 squared. I factored the y parts into y plus 3 squared. Now, if you remember the trick to this, I don't really have to factor that because I already know what it's going to be. The term that goes in right after x is simply b over 2. Remember, before we halved 2 to get 1, positive 1 in fact. And this time we halved positive 6 to get positive 3. And there I can go ahead, I simplify the right-hand side of my equation to get 1. And so we end up having a circle with a center at -1, -3, and a radius of 1. Now, in order to get the h and k, I always take the opposite signs of what I look at or what I see inside my equation. Now this looks like it's the same, but remember, we take the square root of the radius squared to get the actual radius. So the square root of 1 happens to be 1. We can go down and we can graph this value. Now I wasn't super detailed, but you get the idea. My center is at -1, -3, which is here. The radius is obviously just 1, so it goes all the way back to the x-axis, and it goes all the way around. Not a whole lot to discuss with a circle. I think that's probably one of the more easy problems. And so we're going to look now at a parabola. Okay, the general form of a parabola is a little bit different than you're used to, although it can be written just the same as we have before. If you remember that if we look at vertex form of a parabola, it's y equals a times x minus h all squared plus k. That can be written in the same method here. The only thing you have to do is you switch out a with 1 over 4p. Okay. Now we don't have that written here, but you can get the idea, and this works just the same. I get the squared term all on one side equal to 4p times the y minus a value. Notice there's two different variations. Sometimes it's the parabolas that are opened up or down. That's what these are. If it's the left and right side parabolas, then you've got this particular value here. If p is positive, that means it's either going to open up for this one, or it's going to open to the right for this one. If p is negative, then this one will be opening down. This one will be opening to the left. If you remember how the x and y axis numbers are divided up, positive numbers go to the right and go up, negative numbers go to the left and down, then you never forget this part. Okay? Let's look at the next equation. So we're going to look at, whoa, too far. Alright. Take forever. No problem. Seriously? Flippin' A. Here we go. We are looking at your basic parabolas. Now I've put one of each type. I did not put the negative versions, but you get the idea. They would just simply be reflections. We're looking at the vertical axis of symmetry, which formula is x equals h. This is the generic form of the parabola you see here. H, comma k plus p. Here's hk. This is my vertex. My focus is located there. My directrix for this particular one is y equals k minus p. One thing to note, if you look at the distance from the vertex to the focus or the vertex to the directrix, it is exactly p units long. That's why if I add p, I get to the focus. If I subtract p, I get back to the directrix. Now, don't think you have to change the formulas if the parabola turns upside down. The formulas remain exactly the same. What changes is p. Okay, so don't worry about that. Just keep the formulas the same, and it'll work out just the same as it would be if you flipped it over. Okay, so at this point, we're looking at a parabola. It's on its side. All right, the same exact scenario happens, except now, instead of adding and subtracting values to k, we're simply, this is all on the same vertical or horizontal line, so that these all have the same exact y values. So I'm going to change h. So in order to go from the hk to the focus, I add p to get here, and of course I'm going to subtract p to get back, and you can look at the formula x equals h minus p. Note the difference in the directrix. This is a vertical line. A vertical line always takes the form x equals. Over here, you have a horizontal line. The directrix takes the shape of y equals a value. A horizontal line like this always takes the form y equals a number. And just like we did before, I have a parabola. And this is the basic equation. I want to be able to take that parabola and to rewrite it in its standard form and write out the different parts. We want to know the focus, we want to know the vertex, we want to know the directrix. Not going to bore you with the completing the square bit. If you need to look at that, you can go back and rewatch the first part. Be careful here. Notice that when I get down to the end, when I'm done, both of my x and my y values, the coefficients are 1. In fact, positive 1. Notice I had to factor out the negative 2 from this scenario, or this side, to get it to be negative 2 on the outside, times y minus 6. Once I'm in this particular situation, I can see my vertex. I can see my, well, I can't see p yet. I can see 4p. If you remember your equation, this part is 4p. So what we're going to do, we know our center, our vertex is going to be 2, 6, because that's what we see on the x and the y here. I don't know p yet, so what I'm going to do, and you can see down here at the bottom, I've set my 4p equal to the number out in front, and that's what will always work. The 4p equals whatever value you have outside the non-squared term. So 4p equals 2. Of course, we divide by 4, and we get p equals negative 1/2. I went ahead and threw in the axis of symmetry, not that it's a necessary item, but let's take p and find my directrix and my focus. From the equations that we had up top, I brought down the formulas for the right one, for the one graph that opens down, because we can see here that p is negative. So this graph is actually going to be opening down, like you see. Here's a picture of it. I went ahead, I labeled my center at 2, 6. I went ahead and plugged in my k and my p. So it'd be 6 minus negative 1/2 to get 6.5. So y equals 6.5 is the directrix. You can see that written here in this red line. The focus is h, comma, k plus p. So it would be 2, comma, 6 plus negative 1/2, which gives me 2, comma, 5.5. I go over here, I plot that point, and that's my vertex, or my directrix, and my focus. So you have all three parts right there, in fact. And that basically takes you to the end of graphing your parabola. Not a lot of complicated pieces. Just make sure that you know how to find the directrix and the focus, no matter which direction your parabola faces. I think that would be the most complicated part. Make sure you know how to complete the squares well. If you need to really take care of this, make sure that you watch this, and you should be able to graph that. One of the harder concepts is if I gave you, let's say I gave you the directrix and the focus, and I might ask you to find the equation. Remember, to graph a parabola, I only need basically three things. I need P, I need H, and I need K. If I have all three of those, then I can graph that, well, not graph, but I could graph it, or I could write the equation for it. So make sure that you know how to find each one of those values no matter what you're given.